All right, let's talk about exercise 9.28. In this exercise, a 200-gram ball is dropped initially from a height of 2.0 meters. It falls, it interacts with the floor, and it rebounds to a maximum height of 1.5 meters. And so what we're given in this problem is we're given the force as a function of time that the floor exerts on the ball, and it looks something like this. It's a triangle. We're given the width of the base of the triangle, which is 5.0 milliseconds. And what we're interested in this problem is for the maximum force. Okay, so the key to this problem is, I'm going to call the y direction up. The key to this problem is remembering that when a force acts over a time interval, it imparts an impulse and changes the momentum. And so the impulse momentum theorem tells me that if I integrate the net force on the ball over time, now this is a one-dimensional problem, so I'm not going to put vector signs in there, except in the signs of my vector quantities. But when a force acts over time, from some initial time to some final time, I get a change in the momentum. All right. Change in momentum is mass times v final minus v initial. And so the initial speed is the speed that it has just before the collision. Final speed is the speed it has just after the collision. And two things here. All right, the first thing that I want to recall is that this is just the area underneath the curve, this area there. Okay? And so if you remember your geometry, the area of a triangle is 1/2 the base, which is, I'm going to call it delta t, it's 5 milliseconds, times the height, which is f max. Okay, that's the first thing. And then what I want to do is I'm actually going to rename v final and v initial, because I'm going to use kinematics to find them. So I'm going to call v final v2, the speed it leaves just after it's done with contact with the floor, minus v1, the speed it had, or the velocity that it had, just before it collides with the floor there. Okay. And so this is so now I have to recognize that in order to find v2 and v1, really it's just kinematics. Okay, so let's start with v1 here. So during the drop, or from the drop, okay, the initial height is 2 meters. It accelerates under the influence of gravity. So this is a constant acceleration problem. You could draw the free body diagram out. But it turns out that the expression that we want, so this v initial here, which I'm calling v1 squared is going to be v initial squared plus 2a delta y. Okay, and so the initial speed, that is the speed that it's dropped from, so it's dropped from rest, so that's 0. So I can find the speed and then the velocity that it has just before impact. So v1 is equal to the square root of 2 times, well, minus g, caused, as I called y positive up, and delta y is going to be minus 2.0 meters. Right, and when I work all that out, I get that v1 is 6.26 meters per second. All right. Okay. And so after the bounce, spelled bounce kind of crazy. After the bounce, okay. So this is on its way back up. On its way back up, well, it's going to start with this speed v2, right? And its final speed is going to be 0. So 0 equals v2 squared plus 2a delta y, okay, or v2 squared is equal to 2 times g was negative, so I brought it to the other side. And delta y is a positive quantity, and it's 1.5 meters. And so it turns out that when I plug all this stuff in, I find that V2 is equal to 5.422 meters per second, keeping probably too many sig figs, but I'll work that out at the end. And so we find that the speed that it leaves the floor with is slightly less than the speed that it had going in, suggesting this is an inelastic collision. But there we have it. All right. So I can rearrange that expression that I had before. So 1/2 delta T times F max is equal to the mass times V2 minus V1, or F max is equal to, bring the 2 over 2m over delta T times V2 minus V1. Okay? And so now I have to be just a little bit careful. Note that V2 is positive, and V1 is actually negative because it's got a negative velocity, and this is where you might get a little tripped up here. Okay, but we're going to plug these numbers in. So I'm told that the mass is 200 grams, which is 0.200 kilograms. I know that delta T is 5 milliseconds, 5.0 times 10 to the minus third seconds. And I plug in what I had before, V2, which is 5.422 meters per second, minus, and V1, like I said, we found the speed before, but now, V1 is actually negative 6.26 meters per second. And when I plug all that in, I get a maximum force that's 9.3 times 10 to the 2 newtons, or about 930 newtons.